Hello, everyone. Good afternoon, and welcome to you in the last webinar of the first season of the Luxembourg L-DIH Talks. Indeed, today we are concluding this first edition where we discussed in details the entire journey of the digital transformation for Industry 4.0. Today's subject still about data. We will see other examples of using actually the data and how to make sure to make it visible and useful. Let me share with you my presentation to see where we are from our journey indeed. So we are in episode number 9, as I mentioned, and this episode is dedicated to how to use the full data, how to get this data and make it useful to take the right decision. So our guests today are Philippe Kunnen, Senior Project Manager from Stremler, Yannick Brück, CTO from Fujitsu Luxembourg, Benjamin Hoch, Technology Director from Earth Lab Luxembourg, and Fabien Lepose, Process Development and Optimization Manager, Metrology Manager at IEE. As usual, your questions are welcome at any moment during the webinar through the question tab. Please do not hesitate to push any questions that you would like to discuss with our guests. Without any further ado, I would like to invite our first speaker, Philippe Kunnen from Stremler AG, to present us how to use the advanced analytics to optimize operations, in particular for supply chain. So Philippe, please, the floor is yours.
Thank you, Marina. Thank you for your kind introduction, and thank you for Digital Innovation Hub for this opportunity to talk to you. So my name is Philippe Können. I'm senior project manager at Stremler Supply Chain Engineering. And today I will give you a quick insight into how and what data we use in order to create our unique real-time planning and steering applications for optimizing production lines, but also sites, and scaling up to optimizing complete supply chain networks. Usually, what comes to me personally to mind when I go into a new project is that, and looking at data, it would look something like this. What we find is data that is more or less structured depending on the need that it currently serves, what is currently used for. What happens often that besides the main structure, the main data platform that this data is in, you have a lot of workarounds. Relevant data is in a lot of workarounds around this. So our task is actually, how do we come, what is our expectation is basically to make something like this. Something you might see as like a highly effective, efficient, very reactive, highly controlled weapon, if you want to say so, but that gives you a real competitive advantage, because dealing with your data or managing your data correctly is a huge competitive advantage today. So data projects, unfortunately, also have a little bit of reputation that they end up looking more like this. Slow, blocking a lot of resources on the IT for other operational tasks, but also, as the past has shown, you will find a lot of interesting things maybe also in your data. Some more or less uncomfortable or comfortable truths. So it's worthwhile digging into it. And yes, there are areas, local areas, that have the potential to fly. So what we at Stremler look at now, or our goal is to make sure that the potential of all these projects can actually unfold to their fullest potential. And I will show you how. So our goal at Stremler is to ensure the seamless integration of all necessary data. So our goal is there to create a digital twin for planning and control of the integrated supply chain. That means it starts from procurement through production, the different production steps, and ends with distribution. In the end, can be installation at the customer side. So we need to make sure that we have the data relevant to connect the right dots, to correct all relevant decision points for planning there, and that can be also, if you have more complex supply chains, on a real network level. So what data actually are we dealing with when we do that? We don't need all data. It's not so big. It's important that we identify the right data, and it's important that we find that data and have a unique definition of the data where the dots meet, where the links of the chains are. And we need to do this. We have a lot of effort into making to unambiguously define the data that should be in the different fields, and that should be should be aligned throughout the company. And one requirement is that the data should be updated as close as possible to real time, because our systems are designed to make use of the data in real time and to have a decision support in real time. In general, you talk about data. When you talk about data, you talk about master data and transaction data in this area. So what we're looking at, master and transaction data here on the side on the demand side. And here the principle is that this is the key data that is pulling the whole chain. So it's the customer pull, the real order is pulling all the other decisions throughout the chain. And the second element there is the production data. So all data relevant to the production planning. And given this idea of customer pull, that production is pulled by the real needs of the customer there. And then the third point is the supply side. It's the material management. So it is crucial to have these three elements tight, managed together in order to have a reactive supply chain. And where do we get that data from? The data is available because you use it already in your companies, but it's usually an ERP system. Usually what we do in our applications, we add some additional mappings, etc. But like I said previously, we have to make sure that all the data that is in some workarounds is actually, or the relevant data that is in workarounds, also we capture that. So what do we use this data for? At Stremler, we talk about, we have two main principles there, and that is, the one is synchronization. What we do is we synchronize the data and we synchronize processes with the data. So all data corresponding to plannings are synchronized over each supply chain step, and also, so that is kind of like the horizontal integration, but also the vertical integration. So you also have for the vertical integration, you also have to synchronize it over your different time levels or horizons. And planning, and because your planning depends on the time horizon that you're doing it. You have short-term, mid-term, long-term plannings in all your different steps. And for the planning, the main principle of Stremler at this point is the simulation. So we have seen that only the simulation approach allows you really to grasp the reality as close as possible to the needs of the planner. because you avoid all averagings, and you avoid especially simplifications due to your that might come of creating complex formulas or mathematics behind it. On a simulation, with the simulation approach, you ensure that you can include all relevant all relevant dependencies and create the maximum experience for the supply chain manager. So these two elements together then allow us to ensure a realistic scenario planning, and this scenario planning then can be done on different levels. So it can be done for one specific supply chain step. Imagine you have you're in a supply chain step. You're do some assembly work, and you have a shift in the order. So the customer says, okay, the delivery date is shifted, or a material is not available, or other priority has changed. Then with this setup, you will have the possibility to check, do a scenario planning. What are the capacities that I have? Do I have the material available? What are the consequences on the other steps? You will have them all in your on your view. So, and this view is then realized when we talk about the digital twin. And to get to that digital twin, we need another essential element that I haven't talked about yet, but that is the crucial point, and that is the process model. So the process model is the framework which defines what data you actually need. And with the right process model, you ensure that you eliminate all the friction in the internal plannings to speed up to a maximum your decision processes. And also you apply, there are also the whole set of rules how you deal with your plannings. But on the other side, you also need a technology, and that is the real-time, what we have here, the real-time technology, which means that you have the capability to process the data in a real time, so that the decisions are actually ready when you need them. So it doesn't help you if you have what if scenarios, but they take 2 days to generate. If you have only if you only know that you have only 2 hours to decide. So these are the two key areas, key elements there that then together create the digital twin, what we're talking about. So to summarize up our approach is that your data will help you to increase your competitiveness, but the key lies in enabling real-time decision making there. And for that, you need the concept that I explained, which is basically you need to make smart use of your data. You need to ensure that, and that comes from ensuring that you have the right the right process model in place at the first place, and then that you apply the right planning approach and have the technology available to all integrated. And if you have that, then your data will put you into the driving seat of what I think an extremely powerful, to come back to my initial picture of maybe something like a jet cockpit for your supply chain. Or here, in other words, a control tower for not only monitoring, but also actually proactively steering your planning and control of the supply chain. Thank you very much. I think there might be some questions or help.
Thank you, Philip. So actually, there are not yet questions, but I'm sure that they will come up later. You can have an eye on the question tab if there is any question, and then you answer by writing the answer, actually. So, but I do have one. How do you ensure that data that you are extracting or you are getting are correct, really, and sustainably up to date, and you can really use it and use it in an accurate way?
in fact, this is a crucial point, and there we come in a transformation, in the talking about transformation, because whatever project that we do there, there's always the element of transformation, also from an organization point of view, because you have to make sure that the responsibility for updating the data also lies close to the people that are actually using it. Because if the people that are updating don't see the necessity firsthand to use the data, we will have a very difficult time to get the right data quality there. And this you can do because the application, you make the application available to everybody, and all the, or that's not everybody, but the right people concerned, and there will be a process started, actually, of continuously improving your data, because people will start suddenly see the actual result immediately if they improve the quality of their data. It's a very interesting concept. It's like a train that you start that's going on. Yeah.
And then when you use this data, though, so you could consider a feedback, right? Like, how do you use it? Is it to manage the machine breakdown, or to manage the quality, or solve any problems? How do you consider this feedback from data?
Feedback is relevant because it's nice to have a good planning, but planning is always planning. So things in reality go different than you do in planning. So what is important there, that you have that you have the reactivity in the planning to react of change in changes. So yes, we include the feedback data from machines. We don't do it directly. We don't attach directly to the machines, but we for example, if there's an outage, we take that data, we get an event, okay, there's an outage, and then we will replan.
Okay, and then you act accordingly, or you take the right decision, or maybe you would have a standard operating procedures that you would follow for this one, or...
Yes, it's a continuous process.
Yeah. Okay. So I won't take. It's very interesting. You have a question in the questions tab, so you may answer to it. I don't want to take it live. You can just type your answer in there, because I would like to introduce our next speaker, Yannick Brug. As I mentioned, he is the CTO of Fujitsu Luxembourg. Yannick will take us through the important item, which is why we should go for an integrated and governed data platform, right, to tackle this common use cases, in particular for Industry 4.0. Yannick, it's yours.
Thanks a lot for this introduction and for the opportunity to speak here. So I will be sharing with you what we do and how do we approach this kind of challenges with data as Fujitsu Luxembourg. So and to start the introduction just on the topic and why we think it is a very central topic, let me just start with one slide to introduce how we see and how we envisage all the things around a potential customer. So what we have as a vision is called the Intelligent Society, which basically says that we can see each company having the type of architecture layer where we can provide tooling, innovation in order to help them make the difference. And the difference is how you differentiate on the market against competition, against crisis, against environment, and how you could be better. And in order to do so, we provide all the things on all the steps that we see here through technological innovation to make a connected experience between all the different aspects. And as you can see in this picture, we've put data at its center, because it's really data that will be fueling all the differentiators that could come from application, from services, from automation, intelligence, and so on. And one topic to keep in mind as well is everything. When you speak about data, everything is also running somewhere, and running somewhere could be on your data center, in the cloud, on different type of services, or even having a hybrid approach. And just to mention it as well, you can also have different approaches to leverage those data internally, of course, but also externally. And externally would also mean being able to expose it to the outside, to partners, to customers, to third parties, and so on. So basically, in a nutshell, that's how we see different contexts and how we approach things with data at its core. So why is it important to have this in mind? Because, well, it might be obvious for every one of you attending this webinar, but data is really a strategic asset, but it's really difficult to tap into. As we have seen in the first presentation, it's really something that we need to tackle. We need to really be aware of what we are doing, what type of data, and so on. But a lot of time, it's really difficult to get them because it's, well, coming from a different type of sources. It has different type of content, so structured, unstructured type of formats, and also some static, some streaming data, and so on. But once we have the way to get them and leverage data, we can really have a strong added value. And that's the aim of what we have as an approach and what I would be sharing today. So another obvious thing, and that's the last one for today, is that almost everybody says, okay, my firm is trying to become insights-driven. We all speak about data-driven companies and all the things there. But, well, statistically, what we can see is that only 1 out of 3 are really succeeding a little bit on this thing, because there are a lot of projects, a lot of blocking issues that might prevent you for going in the type of company, the type of insights-driven company that you would like to have. What type of impediments are there to prevent from this progression and prevent from getting there? The first thing is, we all know, since I would say for the last years, we all speak about the data explosion. So big data, and then a lot of data coming from all connected applications, connected sensors, and everything becomes connecting, producing data that we need to manage, that we need to do something with that. We also find out that there's another very big blocker, that is the self-service bottleneck, as we call it. And basically it says that more and more people are acting as, I would say, citizen data scientist. So meaning everybody is able to use Excel file, make some statistics, or is able to follow a tutorial on the web and trying to go himself on data. But when you do that on an Excel file on your laptop for your specific sake, okay, you might go and achieve something. But if you go to the data that is in your enterprise, that is stored in some specific programs, it might be very much difficult to go into this self-service mode, and also being able to see what type of data, where it is, do I have the rights to go there, how can I use it? And that's also one of the key questions to solve. Another one is of course, lack of skills and lack of collaboration regarding data as themselves. So it's always difficult to get the skills. It's becoming rare and rare. So it's one of the, I think it's one of the job positions that data scientist that is the most admired and also the most researched in the market. So from the last study I saw last year. And the last one is basically that even if we get access to all this data, it's sometimes it's very difficult to be able to prove the ROI or being able to monetize this data, monetize the insights that are coming on that. So basically, if you can't prove that, you need to make some investment and bring a kind of platforms, tooling approaches, call it the way you want, but there's some investment to be done in order to get those data and get those insights. If you're unable to show that it will bring value and money, you won't have the approval and you won't have the means to go there. So basically, these are the impediments that we see, and we found a way to help on those topics. I just want to deep dive on one problem that is the most common one, is the data silo problem that we all see. So when we start a project, we all see that usually customers and companies have the data they need in order to be able to do the type of analytics or to get the insights they want. But the problem is, data is in silos. Silo could mean departments, it could mean applications, it could mean specific infrastructure or specific part of the company. So if you look at mission critical data, it could be splitted between different applications, and you have to get access to them through security, through technical problems, and being able to put that together to have the picture you want in order to get insights out of it. And if you put on top of all the governance and compliance that you have to follow, it really creates something that is very cost not cost effective and have a lot of workflow. So basically that's the problem a lot of customers see, and that's what we are able to tackle. Why we want to tackle this? Because we have seen by an experience that you will get a higher returns out of that. We are used for years to make the data warehousing project. So we have sources, we collect them, we prepare them, and we expose them through marts or warehouses in order to be able to make some reporting out of that. For the last years, we have seen an explosion of data, and they were speaking about data lakes. Data lakes is basically we just get rid of all these strict rules and we push data as they are in a central repository, and we are then able to make some self-service. Yes, but that was the other extreme, I would say. We need compliance, we need governance as well. So what we are doing is trying to find the right middle between warehousing, pure traditional warehousing, and the freedom of having data lakes, is having a data hub. So basically we take the best out of the two solutions. We say we can connect to anything as they are, so any type of data as they are, but we apply some governance and also some control, so we are sure that it's used in the proper way with the access rights, with all the support to enable the self-service for anyone. So that's basically what we see, and also it enables to manage that into a production approach, I would say, meaning also being able to make all the backup to make the homogeneity of data and being sure that it makes sense. Just one thing I picked out that is important because it's very visual is you cannot do artificial intelligence or advanced analytics. So me saying we cannot have insights that make sense without thinking about architecture of data or of information. And if you just take the two numbers here, so that's why I picked that for the webinar, is 80% of people who are speaking about going into this data-driven company, they do not know and they do not understand what data are required, and they do not know if it's accessible. They know it might be untrusted. They don't know if they could rely on this to make decision, and of course, some also need some analysis. So basically, we are in a situation where, in reality, you have an information architecture that looks a little bit like this. I took it a little bit funny just for today, because it's a car on the left-hand side. It's a car. It has four wheels. It has an engine. It has windows. It has doors. But as you could see, you might have someone in a department that wanted to have a little bit more height for the front seats, for example, because they have a specific business problem. They wanted to have a different engine type at the front of the car because they also had another context. So they tuned something that was at the beginning a classical, quite good car, and they tried to put something there. And we see that I did not put some name on that, but it's really something that they took pieces together and plugged them as they could, and it's working. But yeah, it does not look like as fancy. It's not like as effective, as speedy, as good as you could see on the right hand side, where basically what we were thinking about is having this integrated platform with all the modern architecture that could be there, and bring the governance. So that's, for the visual thing, a more shiny car and more speedy car that seems more appealing. So basically, to be more pragmatic, what we need is having a single platform to be able to manage those and to tackle those challenges that we just saw in the previous slides. And in order to be having that, will let us follow the steps that we have here on the screens, which are basically capturing data, which are collecting, connecting and accessing data, of course, where it is. So in the format, in the situation, in the location it is. Securing in the sense of governance, so being able to find them, understand them, and being able to search them and to put policies on top of. Making all type of analysis. It could be traditional business intelligence, or going more into the machine learning AI space, or doing different type of. Managing the model and deployment, and also the most important thing is having insights. One time is good, but having insights in an automated way, included in production usage. So operationalizing data, so creating applications that take insights and leverage those data is more important. So it's a real process that we can follow, and that brings a really trusted foundation for data. So basically how we do that. So again, I'm not putting product name and so on. I'm just putting concept and how we did that. So we did that before, and we can go in details in the question and answer if needed. But what we would like to see is that there are consumers of data. Basically, these are people who want to leverage data and get insight out of it through applications, through tools, portals, web services, mobile apps, whatever. It's the usage that makes sense. In the middle, you have the core of the approach. The core is having a governed catalog, meaning being able to govern the data, to be able to search them, to make a vocabulary out of it, to say that field is the ID of the customer that makes sense, and this is the description that we have with business terms, and the virtualization layer that is basically we expose a way to access data, and it's transparent for user where data lies, what are the type of formats, should it be in applications, in services, in files, in lakes, in cloud databases, and so on. So basically that's the key, and that's where we speak about Data Hub. So you can, as I said, you can run any type of analytics workload. I just put examples from kind of real life. It's just saying that you can make some descriptive as we did before. So basically, I'm driving that fast, or I'm having that amount of liters of fuel in my car. You can make some prediction. They're saying, okay, I need to fuel again in some minutes. And moreover, going into the cognitive space, meaning I can speak to my car and get things. So that's the type of applications. So now I know I still have 1 minute and something in order to finish. I will just jump to an example to be sure that we have the last picture in mind with a concrete example. So I will mix those 3 slides, which are 3 generic use cases, into the last one, which is an example. So I will just go fast on that. So managing data where it is for different type of users, different type of sources, and the kind of usual processes described in the middle of the slides that happens in everyday life in every company. Building foundations to go to advanced analytics and maybe artificial intelligence, and also being able to govern them, so being able to comply with regulation and so on, such as GDPR in that slide. If you understand where data is, what data is, and how to find them, you can easily find data that is under this regulation and make action out of it. So if I take my example, and it's 5 slides, but just an example, that you have a basic story. You have 2 suppliers providing 2 different pieces that are in a factory, bringing a product, going into warehouse, and then stored in a store. Basically, what happens is, if you go to the question how to identify items, you will get different type of IDs speaking about the same item, but in terms of data, it is through different ways of identifying it. For supplier 1 and 2, it could be 2 different reference number. For the factory, once it is built together, it's a serial number. Okay, makes sense. But again, you have 2 ways of identifying the same item. If you go to a warehouse that hopefully has RFID, for example, you won't be having the serial number, you could have the tag ID. The tag is the thing that is basically on the tile that you are looking for, and that's technically what you will get if you want to find them. So you have to make the link between this tag ID and the serial number. And again, if you go to stores often work with barcodes. I took this example here. So if you use the store and the tools available on the store, you will identify the product by its barcode. So how to make the link between all the steps and being sure that you speak about the same item. Technologically point of view, you could have also different format, CSV files, ERP with specific format, RFID, so meaning you have to read them, and also for the barcode, specific readers for the barcode. So you have different type of real life constraints that says, okay, if you don't have this type of platform, if you are not able to centrally manage those things and access them centrally, you are not able to answer a very basic question, such as in this solved slide, which is, where is my object in this construction and delivery project? Because what I see is at the end, I'm a consumer, I'm at the store, and I want this project. So what step it is it in the supplier side? Is it in the factory? Is it in the warehouse? Where it is? If you're not able to identify those information with what you have, and then say, that's the barcode, and it's linked to this serial number in the factory, and the ERP says that's the status, you are not able to know anything and to predict. So that's just an example where having a centralized and unified platform could help in this topic, and addressing questions, translating it into and getting rid of all the technological constraints and all the different type of systems to answer basically one question. So that's just an example, Marina. So I'm ending my talk with that. Hopefully there are any questions, and of course it's a huge topic, so we can go deeper in the question and answer part.
Absolutely, and we know how short it is, the 10 minutes or 12 minutes, but these are very interesting subject, passionate subject, and I know that you guys, you wish, and you can talk hours. Anyhow, the questions will come, I'm sure. Please also feel free to participate with the existing question if this is something convenient to you. I would like to ask you one question, Yannick.
Yeah, sure.
What about the ROI of such a concept and approach?
There might be two things in that question. The first one is it's oftenly we think that it's very expensive to go into that field, and really the entry cost is very expensive. And I can tell it's not true, because of course, if you want the full platform on premises and go there, it will cost. But we have plenty of cloud services and plenty of ways to use the free of charge services to start things off. And I think more than tooling, it's also a philosophy, it's a methodology that have to be followed. And based on that, even if you have a small entry cost, let's say, you will have a very fast ROI, because it will leverage data that you already have. So it's just a tool to get a faster access to data, and then to be able to get insights and make decisions. So the question is not what is the ROI in that case. The question would be more, what is for you the cost of losing, I don't know, a box of items? What is the cost of losing one day in the delivery? What is the cost of anything? And then I think the answer is quite easy to solve.
Thank you so much. Again, sorry, we need to move on.
Sure.
Thanks so much, Yannick.
Thanks
Now,
for the
our
invitation.
next speaker is Benjamin Ucht. He is the technical director from Earth Lab Luxembourg. He will still in the same, of course, discussion about data, the importance and the innovation when we use AI and advanced analytics. So, Benjamin.
Thank you, Marina, for the introduction. So yes, I wanted actually to introduce you with a kind of buzzy topic such as AI and advanced analytics. I think thanks to the two first presentations, you already got a nice introduction on basically what are the different aspects and importance of the data. What I wanted to give you with this presentation is a short insight of basically what is behind AI. So just looking behind the scene and looking on what are all the possibilities that this can give as a kind of evolution of what has been done already since a long time. AI is part of what we call the fourth revolution. I put in this slide a kind of wrap up, because I'm sure that you will have at one moment the question of, or maybe the feeling that AI is going to replace or to I will say, just constrains the human. And it's not really the case. And I have, of course, my personal opinion on that. But I think it's important to mention that AI is basically part of the constant evolution of industry and the technologies. So we had this four revolutions, starting with the mechanization, with mass production, with the automation, with the new technologies that are basically making all this large amount of data and the requirement, as it has been very well described by the two presenters, of making a good management of the data. AI is going into a kind of new area. It's here to help you in order to basically go farther than what is called automation. And it's important to distinguish automation and AI. Automation, basically, it's what we are seeing already since a decade. And we are seeing now a lot of this automatic management of production chains or whatever kind of building system. And in that case, basically, how this is built, it's a kind of fixed area where a coder, for talking about a software, or an engineer, mechanical engineer, talking about the hardware, are being able to basically design a system in order to react automatically according to some internal measurement or operations. AI can be included in automation in a certain way, but AI has a new facet. The new facet is basically to mimic. I like this word, mimic, and not replace. Mimic the human by making decisions which are closer to what a human is really thinking and how the human is really interacting with the environment. So in automation, you can have some AI piece of software. In these systems, you have, in this case, some interesting cognitive approach where you can have the system not only applying rules, but taking decisions. This is where the difference is, the taking decisions. I can already hear you saying, well, but we are hearing about AI. Let me guess, you heard about AI just for probably a kind of automatic driving systems, all these very strong discussions in how can be autonomous vehicles driving later on. And so you can already probably imagine this is very complex, etc. But no, at the end, artificial intelligence, it's a kind of new area where you don't have actually to, I will say, imagine that this is totally disturbing. It's an application of a continuity in terms of mathematics and the application of, I will say, studying decision-making systems. So it reacts on the same, I would say, approach and procedures. You can, by using different well-defined procedures, using the right tools, ensure that you can go from the data to a decision-making system based on AI. AI is unpredictable. No, it's no. AI is predictable. At the end, it's a system which is totally automatic. The point is maybe we don't understand it, or we don't have enough insight to understand what will be his reaction in the future. For that, once again, already all the research area, but also now the industry, has been able to build some quality metrics in order to clearly assess what will be the quality of an AI model, and even help you in order to anticipate what will be his reaction. Finally, difficult to operate. I put a no, but I will say it's one of the challenges that still remain, because indeed, AI relies on software which are sometimes difficult to operate. But if you look at the recent innovation, with this cloud approach, with this hybrid cloud even, you can have a lot of different possibilities now where you can easily deploy your AI and operate it at scale. But where actually we can really go and imagine that AI is making a sense? Actually, I put this nice picture on the left. I like it because, it's exactly what I can see in a lot of use cases. People coming to me and saying, I want to use AI, but I'm not sure. And at the end, most of the use cases, they are trying to do both. But at the end, if you do both, they are not convinced, actually, that this is really making a sense for you. In general, for making AI, there is two major areas. One is called optimization, where actually this is already a kind of operation which is already implemented somewhere, manually or with an automatic system, but where AI can probably add another dimension by maybe being a bit more flexible on your usage. And in that case, you are going to this kind of new marketing areas where you will have, I would say, tons of new applications. But at the end, you know that where actually you can make AI is either to optimize or to create new services. Important is everything is based on data. So you need to have, of course, a large amount of data, sometimes not so large. I have to say it's a kind of busted approach as well. Sometimes you don't need so much data, but you are already able to create some AI system on it. You need, of course, in that case, to really be able to apply this AI and at least on a minimum, I will say, amount of data or operations for it to make sense. If this is just to make 1 or 2 decisions per day, yeah, definitely a human is more applicable for that. And at the end, I will say where it's making the most difference is probably where actually we need to feel somehow where these different areas are making a sense. This is why I put this last sentence on this slide. And it's probably where the success of AI will come now, on this capacity to easily experiment and to try by itself some AI models. Yeah, I know you are looking at this slide and you are saying, oh, No, he will explain everything. That will take hours. I know, Marina, but no, I have a limited time. So I put in this slide also for later, for you to understand that there is tons of kind of application of AI that are making a lot of different operation and decisions. You have on the top of this slide a lot of operations which are related to something called data mining, where you can imagine that you have some table data and you are trying to analyze it. On the bottom, which is more my specialty, it's all about what we call computer vision. So extracting intelligence out of images. So replacing somehow the eye of the human in order to define or detect things. I put here a couple of examples. I like the one on the left, with the mask. It's quite recent and very good in the context of the COVID, I would say, lockdown and removal of the lockdown, where we can imagine to have AI, and it's already in operation, an AI detecting if you are really wearing your mask. You can have other kind of AI which are going up to already write a sentence which are describing a picture. Try to transpose this into a lot of different use cases within the industrial operations. I put in this slide a couple of areas where you can imagine to use AI. I will just pass through very quickly. Quality checks. Imagine that for a lot of industry, there is a very strict procedure in order to measure what are the output of a production chain, measuring if the dimensions are correct, if the manufacturing has been done on the right order, etc. Most of the time, this is done, I would say, statistically. So we are measuring 1/10, 1 on 100, 1 on 1,000 piece, and ensuring that somehow this is representing the reality. If you have an automatic system, what is preventing you to just monitor everything? Predicts equipment failure. It's quite related with the second one, which is equipment preventive maintenance. Imagine that you can anticipate that you will have a failure on your machine. Give you an example. I made a model some time ago just to detect sounds out of manufacturing machines. And the sounds are usually, always quite regular and always having the same tones when you are doing some production. And sometimes you are hearing a strange noise. And this strange noise is probably starting to be one of the major indicators that, of course, then you will have a problem. You can also go to the more marketing side in order to detect what will be the future product demand according to other that will help you to anticipate and be the first to provide a new product, or even reduce your churn. And finally, maybe also on a totally other, you can also this kind of AI approach in order to detect what can be the fraud that you are supporting and also the cyber attacks you are receiving. To create these different AIs, the process is always the same. And this is why I like it so much. At the end, it's always a kind of automated process as well to create an AI. Starting with a collection of the data, defining the way that you will, I would say, implement your AI or even create yourself a certain model, train, test, and finally operate. And this chain can be also automated. And this is where probably the success of AI will come now. Thank you. I think I have just made it on time. I don't know if there is some questions.
Yes, sorry, I was looking to unmute myself. Thank you so much, Benjamin. AI is my favorite stuff because I know how much could be powerful and how much we can use it really to ease the procedure, in particular for industrial companies. So we need data, right? And we need them good data, if I may say, structured data to be able to get the maximum benefit. So what would be, in your opinions, the failure reasons then? Is it only data, or there are some other factors that could get into this implementation?
Yeah, very, very nice question. I think there is indeed, the first one is about the data quality. And several times you can imagine that you have the perfect data lake. I will just point you to the image of Yannick before with this very nice car. But the reality is often very different. But there is tools as well in order to analyze it. But if you don't take the time in order to assure to assess that your data quality is good, indeed, you will get a bad model. But there is another reason. Usually you may fail also if you don't define correctly exactly the goal of your AI. It's also important before to start any, I would say, design of an AI or creation of an AI or coding of an AI to really ask you the question, what do you want this AI to do? And for example, do you want to count things? Do you want to detect things? Do you want to exactly position things within an image? This is totally different approach in AI. So asking you the right question is helping a lot in order to ensure that you will be successful.
Yeah, thank you so much. There is a question as well. I'm going to, so Yannick is also interacting, but do not hesitate. The question is how to make sure that decisions made by AI do not derive over time. I think we need your also answer here because this is very important topic. Yeah.
One of my favorite questions is about this explainability topic out of AI. I'm working a lot on this, and definitely it's an important one. Of course, you will have to ensure that your data is not corrupting some other AI. We all have in memory this example of Microsoft that have created at one moment a chatbot, and this chatbot became very quickly racism because of the questions that are being asked by the people online. But there is tools now also as well in order to ensure that you have some good explainability of the reaction of your model. Of course, this is sometimes difficult, and it's not the answer that people are expecting to have when designing an AI. You know, we are all, I would say, expecting to have the magic directly done by the AI. Sometimes it's not so easy, and sometimes you need to assure that you have the right explainability approach, which is performed time after time in order to ensure that you have the right quality approach.
Okay, thank you so much. So again, feel free to interact in the chat and then share your opinion altogether. Thank you so much, Benjamin.
Thank you.
Yes, let's move to our last speaker. So Fabien at IEE will go and will give us some case study about the digitalization processes, indicator, and how IEE has been implementing these processes based on the data. Fabien, I'll let you start.
Yes, good afternoon. Thank you for the invitation and the opportunity to show what we are doing at IEE in terms of digitalization of process indicators. So I would like to briefly present IEE, myself, and then I want to show you a brief overview of the strategy of IEE in terms of indicators. And then I have 4 examples out of many others about indicators we have in the company regarding program management, quality claims, metrology, and automotive spice capability determination. So IEE is an automotive company. We have our headquarters in Bissen, Luxembourg, and different divisions all around the world. We are developing and producing sensors for the car manufacturers, different sensors, of course. We have also a device for people counter to manage buildings and tailgate detector to prevent unauthorized access to secure areas. And we have also some smart sensor in the shoes and other applications. I'm at IEE since 22 years now. I started in the engineering department and then to the responsibility of the process design and optimization. And I'm now also responsible for the metrology laboratory. The strategy we have on the indicator is that we clearly understand in our environment that we have many different disciplines, many different tools and methods, and so a lot of data that is coming out. But we also understood that there is no one tool solution that can be the umbrella for all the different disciplines we have in IEE. So we have started with our own system, and we are collecting data from the different data we have, so we can do data mining and extract data from Excel sheet, from a different database, from SAP, from Jira, and from a tool called Lynx that is a project management system. All this goes into an ETL that makes the extract, the transformation, and the load. And finally, the publishing is done on one common tool, and that is where the common tool is done. So first example I have is in the program management. The IE project timing are implemented into one tool, one common tool called Links. And this tool offers the possibility for the colleagues in the department, in the development department, to see the task for the different projects on a web service. So the duty of, we call them task manager, is to update the status of their task on a weekly basis. They have to say when the task is not started, when the task is in progress, and when the task is done. And they have also to indicate the remaining time before the finish of the start. This is important to be done on a weekly basis because this will allow then the timing to fit to the reality. With the timing, we are also managing the risk for the deliveries of the project and also doing some resource management. So it's important to fit to the reality. Previously, to control this, we had to extract a large XML files from the database, and it took about more than 16 hours to provide reports and indicators on all this project management system. And of course, the frequency was only done once a month, where before I was explaining that we need to have this weekly update. So that was too long. So now we have an automatic tool, and the indicator extraction is done once a day, the computation as well. The report is available immediately, and instead of spending our time on the creation of the report, we can spend it on the analyze. And that's one of the things we did. You can see on the right side. So this is the task compliance. It's in fact the percentage of tasks that have been updated once a week. And we see that we were going down from 70% good into the red area to 40%. So there was clearly a disconnection between the timing and the reality. So we did screenshot of this report and send it by mail to all the different team members to make them aware that we were going down and we would have a disconnection. And we can see that within weeks or a few months, we could ramp up to more than 90% of compliance, and we could sustain this for several years even. So this helped a lot to show the indicator, but also to have a free, let's say, and daily available indicator. Another example is in the quality. So we receive quality claims from the customer, and those are reported on the ERP system, and they have to be resolved with the AD method. Our commitment is that the first 3Ds of the quality claims will be done within a day. Hopefully, potentially, we can close them also within 15 days. So like before, we had to extract data from the ERP system. It took more than 5 hours to get all these indicators ready. And so the frequency was done on a monthly basis, where really the indicators was needed on a daily basis. So now we have the automatic system running, extracting the file twice a day to fit to our worldwide time zone of the IE activities. We have immediate availability of the report, and also for the quality team, they can see the information directly. And we can see now on the table, on the graph, on the upper graph on the right, that on daily basis, we can see where we are regarding to the indicator, and if to the target, and if I would select the table, I can then see the list of quality claims and which one are getting longer, so we can react on them. It's also, this tool is also showed when we have customer visits, and they're always really happy to see that we have invested time and money in these indicators in this tool to commit to what we want to commit to these targets. Another example, so yes, here we have also for free, let's say, several information about the quality claims that help us to then analyze them. Another example is on the metrology laboratory. So we have a target to meet, to calibrate 99% of the devices in time, and those devices are spread all around the world. We have about 3,800 devices to manage. So I was also there extracting Excel sheet from the database, and it took me about 4 hours to provide a report. And so the frequency of the reporting was done on a monthly basis as well. Here now we have a semi-automatic reporting, because so far the connection between the database and the system is not yet automatic. So, but it takes me now only 10 minutes to provide the information, and we can have a look twice a month. So we can keep then our target on track by visualizing it. Last one is about the automotive spice capability determination. We do verification via audits about the compliance of the project regarding our quality management system. So by the same time, we verify that they are compliant with automotive spice, and there we raise deviations. Those deviations allow us to first calculate a first capability, and then once the deviations are closed and implemented, the calculation is done automatically. And I can show you here an example. So on the right side, you see the kind of report we receive, and you would see some numbers that give the level 1 and level 2 capability just after an audit. Once the deviations are implemented and closed, this capability increase automatically. And so it's an indication for the quality people that, first of all deviations have been really close, and that the project achieved the right capability level required by the customer or by IE. And through this gamification, it allows the team to demonstrate better results in live. So that's it for the presentation. If you have any question, I'm ready to answer.
Thank you so much, Fabien. I have a question. So you went through this overall digitalization of your indicator, and it seems easy to us, like you described it. Of course, it's always easy afterward. But what was, from your experience, the most tricky part of digitalizing this indicator?
Yeah, from my experience, so if I summarize the process of extracting and building an indicator, is we need to have the department manager or the process owner who needs to identify which indicators will be the right one. And then we build this indicator and we do the data mining. And at the beginning, I always thought that data mining would be the most difficult part. And in fact, really not. We have so many data. Now everything is electronic, there are database. So data is really available. With an IT team knowledgeable about a database, it was really easy to gather the data. The most difficult thing was for the department manager or the process owner to really identify what exactly is the indicator. It seemed for them that it's free, so they wanted to have done many indicators, and that would really be difficult to follow the right one. We can make also difference between indicators and key process indicators, so there is categorization to be done. But also the acceptance of, especially in service, the teams will be, let's say, kind of rated based on that. And what will be then the management decision if we do not reach the target? What kind of action will be taken? So this is still the most difficult side of, from my experience, the indicator building.
Okay, thank you. So you have also a question. I'm sharing it on the screen. Have you implemented a human change management strategy to achieve these KPI improvements?
Oh, human change management strategy.
Yeah. Well, you've
Yeah,
mentioned, so you need the buy-in of your management, yeah?
Exactly.
Yeah.
So this is then, let's say, probably the first indicators were without this human change or human collaboration, and we adjust numbers to rate. So yeah, we always try to, let's say, demystify these numbers, explain really carefully to the teams what it is, and we see also that when an indicator is well selected, the team will really be behind it and will use it like we are using many indicators in our life, and not only for the business. So it's important, yes, to explain before and to get the collaboration of the colleagues in that perspective.
And we have another question. That was one that I wanted to ask you. Thank you, Raymond. So did you have to rely on a lot of collaboration in your projects between IT management and your department to get the job done? Or were you able to manage on your own, right?
No, it is not possible for only one person to manage it. So it's really a complete team collaboration. On one hand, we need the vision of the department manager who needs to have indicators in order to steer his department or his process. We needed also a very strong collaboration with our IT team in order to do this data mining. So it's really a team effort.
Okay, thank you so much. We don't have a question so far, so thank you to all our speakers. I would like really to give, again, it was a very, very accurate topics, nice presentation about these topics, and very important discussion. Thank you so much for your attendees and then for your participation and the speakers. So, what is the next now? As I mentioned in the beginning, this is going to be our last actually episode for this season. We are ending here before the summer, so there are no webinar anymore before September. In September, we are going to make the episode 10, which was planned to be done now, but because we want to make it really on site, and it's not going to be a webinar. We will have people sitting together and discussing together, and then we will go and review a little bit and recap what we've been discussing during these 9 episodes actually, and kick off the next season. The topic of this next season, it is going to be really interesting. We will be talking about digitalization for sustainability in Industry 4.0, how we are going to combine the digital transformation and keeping the sustainability in our manufacturing companies, our plant, and using all this technology and combine all these topics together. So stay tuned. We will be back in September after the school, after the holidays, summer holidays, and we will kick off our next season. We will keep the webinar format, but we will make this episode 10 on site actually. So thank you so much for everything we've done and you've done, and thanks to all our speakers since February, and looking forward to see you again. So you can watch the replay of all the episodes on the link that you can see on the screen. Thanks again. Have a wonderful summer and see you in September. Bye-bye.